So another paper is that you've written, Space-Time is a New Frontier, Advanced Material with Applications in Physics, Engineering, Chemistry, and Cosmology. So the starting point of the present work is a theoretical and experimental resolution of one of the most basic fundamental problems of physics, namely the very existence and reality of the ether. So we're kind of on that topic once again. These basic philosophical and scientific insightful results in theoretical physics and cosmology are converted here into a serious attempt at actually realizing an old futuristic dream, namely obtaining free energy from empty space or space-time singularities as thought of by visionaries such as Nikola Tesla and Sir Roger Penrose, with undreamed of possibilities in physics, chemistry, engineering, and cosmology. Our mathematical and experimental verdict, which was announced recently, is that the ether exists and it can be equated to the empty set of pure mathematics. More precisely, the ether may be understood for all mathematical and physical purposes as being identical to the empty set underlying the Penrose fractal tessellation universe, which obeys the Alan Kone corresponding dimensional function of his non-commutative geometry. From this astounding conclusion, it is relatively very easy to conclude from the above that cosmic dark energy is simply the energy stored in the ether empty set, so that the agreement between the theoretical calculation and the numerous accurate cosmological measurements may be taken as an indirect experimental confirmation of this spectacular model for the ether. In fact, the mere fact that Penrose fractal tessellation is a well-known and valid model for quasi-crystals, that is, a real material with five-fold symmetry, as well as for the cosmos at large, is a sufficient fact to reinvigorate an old analogy between photons and phonon. Not only that, but far more importantly, one can look for methods of harnessing the energy of empty space-time using nanotechnology as a scientific fact, not fiction.
Yes, I think that was what I was talking about mainly when I was with you in Florida in this remarkable conference.
When we did the universe as a golden supercomputer.
Yes, exactly. And I must admit here, again, the encouragement which I got indirectly from a very delightful and very nice Nobel laureate, Frank Wilczek. Frank is a very modest man, extremely ingenious, and of course, it's easy for his position to be courageous as well, but he's courageous because he's a Nobel laureate. He is the fairest person of clout I ever seen coming forward and saying that empty space is something and not nothing. That's what I was saying, but nobody listened to an engineer who is talking about this thing. But when a Nobel laureate, with the authority given to him through this prestigious prize, say it, a lot of people listen. Although nothing happened really, except I was encouraged. And I wrote the paper. Again, stressing things. Again, I told you about the factor of fear. You are always afraid of opposition. I mean, Newton hid a lot of things he have written because he hated opposition. No, I'm not as neurotic about opposition as Newton. But nobody liked to be called names,
Sure.
It would be nice if you don't like my ideas to say, well, I have different opinion. The British are very polite, but not everybody is polite as British. So really, this was putting what I have said before in other paper, but more vigorously encouraged by the fact that Frank Wilczek, together with a very, very talented scientist and communicator. They were discussing that on a video is on the YouTube.
Oh, yeah, yeah.
Yeah, you know.
I know.
I have a blue shoes and he had a red shoe.
Right, right, right. And he also, if I may add in, and you'll probably get to this, he recognized the role of the golden mean.
Yes, yes. And it is incredible, really, now. You know, injustice is where you congratulate or condemn, where you done the opposite in another occasion. There must be a precedence. If you say, this great man, I've done this and this, using the golden mean, and then the next judgment, this man have to be hanged because he used the golden mean, there's some gross injustice here. You have either to condemn all the way or you approve it all the way. So, any case, for the anion, which is an imaginative invention by Frank Wilczek. He didn't get the Nobel Prize for that, but he got it for the strong force. But it is now official that the easiest way to deal with the anion of Wilczek or Frank is through the Fibonacci model of that. That means the golden mean, and if you follow the topological theory of quantum topological theory of computation, you'll find the golden mean coming everywhere. And that's what we have been saying for years and years and years. And I'm not unhappy that other people saying that. I hope just they pull in the right direction, whether they acknowledge that we fought for that or not.
But the odd thing is, and you've noticed it as well, they're often very hesitant to use the language that we've used before. Finally, with the anions, these non-abelian anionic models, like the Fibonacci anions, they'll start using the name Fibonacci, and even they'll recognize the language of the golden mean. You pointed this out to me the moment we arrived the other day.
Yes. One of the weakness of my personality and the weakness of people inclined like me, that we don't use two tongues. One, when we are talking publicly, and one, we should really, in order not to unwittingly solicit the attack of other people more. You know, you either say the truth or you don't. And I see it in that case. I shouldn't. This is always fading in black, but not black and white. There are gray and dark gray and light gray, silver gray. So, but I tend in such cases to be black and white, which is not very clever politically. But I think on the long run, nothing remains except the truth.
Right.
Yeah.
Absolutely. And we're all, the things that we had decided on at the very beginning, we're after the truth, and we see love at the heart of the entire enterprise.
For instance, I really, the first time I met Professor Frank Wilczek. We were on a boat on an occasion where Gerard Toft invited us. And he is an extremely pleasant person, and I wanted to invite him quickly to Saudi Arabia and get him there. He got the Faisal Prize for Science. Yeah. So he was in Saudi Arabia, but I already have left Saudi Arabia. And I really intended to have more relation with him because he is pleasant to work with. He is a student, also very ingenious, more intense person, but very, very genius. And I should say, he helped me a lot with his theory of heteretic superstring, which is Nobel laureate David Gross.
David Cross.
I did immediately realize that dark energy is connected to the quantum wave in the sense of David Bohm.
David Bohm. Mm-hmm.
And my model could be rephrased in the language of David Bohm, but then the mathematics have to remain the same, because his notion were not as strict as empty set, zero set, something like that. But I knew exactly it's going to be roughly 4% to 96% dark energy, and 4% due to the quantum particle, which is the zero set. And the 96 is the quantum wave or the empty set. But I had also the benefit of an incredibly ingenious Israeli. He is actually from Ukraine, Dovrochik, Erne Dovrochik, whose son, as I mentioned yesterday, died needlessly in a war with Egypt. Dovrochik was the president of the Weizmann Institute, one of the best universities in the world for research, particularly in chemistry. And there's my friend Itmar Prokacha work also, a very, very dear Israeli friend. Now, if you have something more than 4-dimensional manifold, then 96 of the volume will be at the surface, and 4% inside. Even if you know nothing, you know, boy, this is a model for the dark energy. But how can I discriminate between ordinary energy, pure dark energy, and dark matter? That would have never been able with these two models, except via the simplest way, via the work of David Gross on a heterotic string. He had an incredible dynamic. He combined two theories, which seemed they're successful each in its part, but he combined it in an imaginative way, which is very difficult to conceive anybody except David Gross to come to it. And the courage also. He had already the Nobel Prize, so he's not afraid. Fear sometimes becomes very destructive for innovation. There's something called the old string theory, not superstring, but string theory. It's called the bosonic string. It's being created by an Italian, Veneziano, and a Japanese-American, Nambu, who was a friend of Prigogine. They found only a bad thing about it, about this theory, which explains the strong interaction. The strong force which is keeping things together. It needs to admit that space-time dimension is 26. We know only that there are 4 because of Einstein. We feel 3. We accept time to be an additional, but 26, where the hell this come? But it works. And when you do that, there's something called anomaly cancellation condition. Everything disappears, but you have to have 26. You don't see them, too bad. But result of experiment, any theory, become fine. But it didn't work for anything else. And then came Michael Green from Cambridge, and Schwartz from Celtic. I know them both personally. I met them in Alexandria. I met them also in other places. And I had a very, very engaging talk with Schwartz, who was really under attack at this time from everybody that superstring is nonsense. And he didn't care about it. So in any case, they had this superstring theory which worked for all interaction. Bit complex. It needs a symmetry group called E8, E8. It have 496 generator. symmetry group, E8, E8. So here comes the ingenuity of David Gross. He said, no, I'll combine those. This theory needed 10 dimensions, not 26. I'll combine those. 26 dimensions are running in this direction. They will be opposed by 16 dimensions running in this direction, and 26 minus 16, as everybody knows, is 10. Now, this was hard to take. It worked. And because of this division, I was able to devise a scheme to say, roughly, one from the 26, which is the largest dimension of all, I need 4 for space-time, to remain 22. That would be what I would divide with to get the percentage. I divide by 22. And now, the other one, I will write the 26 in a different way now. The 22 in a different way. I'll take 1 for ordinary energy. 5, Kelvin Klein. 5 for dark matter. And 16, I call them the 16 boson of David Gross, for pure dark energy. And roughly then, but they are coupled. 1 over 22 give you really the 4% or 4.5%. 5 divided by 22 give you 22, roughly. Percent.
Dark matter.
Yeah. And 16 over 22 give you the rest, which is 73.
72.
I couldn't, it was so lovely. I couldn't. So I really owe this heterotic string. They call them, in jest, but with a lot of love, the Princeton Quartet, because it was David Gross and 3 of his students who developed that. And it was such nice music. They call them the
Princeton
string
Quartet.
The quartet. I'm very grateful to David Gross that he done this theory. I'm not sure he's grateful that I used it to calculate things like this, but that is a wonderful thing. He was thinking about something completely different than me, but he was right in his own right, and I'm right in my own right. And that is a wonderful thing. If you are right in your own right and he is right in his own right, you can combine things and you get something even better.
This must have been back when both Garnet and I were invited to Alexandria. You gave your presentation. I remember your excitement because, you've been excited many, many times, but I remember that was very, very, a very special discovery.
Yes. I couldn't sleep all night. And I jumped at about 5 or 6 o'clock. I wrote that. I knew it's right. And I couldn't wait to tell it to the whole world, Nobody can take that from you.
Right.
They can deny you whatever, but they cannot deny you the joy coming from inside. It's just, here you have a guy dying, and he's so happy that he is dying for somebody to live, to whom the bell tolls. When Gordon was his name, and he knew he can save himself, and the fascists are coming, and he's killing, so that his beloved girl can go escape. There are certain things, no matter what it is, you will be happy.